Okay, so in this video I want to look at Chapter 7 notes, the first handout, and we're going to do number 2. So this is another thing that's growing at a certain rate every year. Just like the previous problem, it was about tuition growing at a certain rate every year. Right now we've got a town and the population just reached 6,000, and it grows at 3.2% a year, and we want to figure out what's the population in 1 year. Well, 3.2%, if I start at 6,000 and I want to add 3.2% of that to it, then I need 103.2% of 6,000. So really what I'm going to do is I'm going to take 6,000 and I want to multiply it by 103.2%, which, remember, you got to convert that to a decimal in order to do it. So we're going to do 6,000 times 1.032. And let me get a calculator up here. Oh, of course it doesn't work, so let me restart it. So 6,000 times 1.032. 6,192. Now remember, the 103.2%, the 100% is the 6,000, and the 3.2% is the extra increase. So that's how many people there will be. Okay, let's look at B. What's it going to be in 10 years? Well, if you remember from the previous problem, the way to get the next year, like in 2 years, we would take 6,000 times 1.032, which is 6,192, and then we'd want 3.2% more of that, so we'd multiply it by another 1.032, which is the same thing as squaring it. So that would be in 2 years. And in 3 years, then we'd take this answer and multiply by another 1.032, so it'd be 6,000 times 1.032 cubed, right? So I can keep going like that, and if I went all the way down to 10 years, then the population at 10 years would be 6,000 times 1.032 to the 10th. So let's figure out what that is. Where's the calculator? There it is. So it'd be, I'll just call that back up. Whoop. To the 10th. 8,221, well, 0.44, so let's just round it to the nearest number because it's people. Okay? All right, so let's go on. Next one is in C years, or sorry, T years. T years. Well, we know that for something that grows according to a certain rate, then, a certain percentage rate every year, then you take the initial value, 6,000, and then you have the 100%, which is 1 in decimal form, and then we're going to add to it the 3.2%, and then we just need to multiply it by 103.2% over and over and over again for however many times we grow by that rate, so to the t. So here's our general formula for it, right there. Now, D is kind of a different question. D says, when will the population double? Right? Well, the population doubles when P of t, right, when the population is 12,000, because it was originally 6,000. Whoops, not 120, 12,000, right? Originally 6,000. So, in this equation right here, I'm going to replace the P of t with 12,000. So 12,000 equals 6,000 times 1.032 to the t. Now to solve this, we want to isolate the term that has the t in it. So I'm going to divide everything by 6,000 to get the 1.032 to the t. So divide by 6,000 and divide by 6,000. And then over on this side, the 6,000s cancel. And on this side, I get 2. So it's 1.032 to the t. And we don't actually have any way of solving for the exponent. We've never had to do a problem where the variable is the exponent. So we need a trick for getting the variable out of the exponent, and that's where this new idea comes in. And the new idea is called logs. And if you scroll to the bottom of your page, I added the trick in there. Okay? Here's the trick. If you have something in this form, you can rewrite it in this form on the right here. And I realize that looks worse, but there's a button or a series of buttons you can hit on your calculator that'll do that for you. And that's why it's convenient. And those things are called logarithms. The way you read the thing on the right is you say C equals the log base B of A. So if you look up here, I'll rewrite that rule right here. B to the C equals A. That means exactly the same thing as C equals log base B of A. Okay? So in our problem, let me rewrite our problem so that it looks like what's right here. The B is 1.032, the C is a T, and the A is 2. And then when I rewrite it, I'm going to have C, which is 1.032, equals, oh no, sorry. Nope, sorry, C is T. Right, C is the exponent. That's what I'm solving for. T equals log, and then the B is 1.032, and the A is 2. Okay, now, how do you type that in on your calculator? Well, it says down here, to type in something like this, you push alpha F2 and then choose the thing that says log base. So, let me find the calculator here. And if I go alpha, and then F2 is really the window button up on top. And then notice option 5 is log base. So if I pick that, notice it actually leaves blanks there where I can fill stuff in. So I'm going to put 1.032. And then over here, I'm going to put a 2. And then if I hit enter, it says T equals 22.006 if I round. And T is years, right? So it's going to take 22.006 years to double the population. And you can check it pretty easily. Remember, it's supposed to be 6,000 times 1.032 2D, and then that power, which is a terrible number, but the idea is that's when the population's supposed to be 12,000. And there you go. Right? So this is correct. So logs help you solve when you need to find that exponent on top. And just this rule is incredibly important, and you're going to basically have to memorize it, but make sure you practice it a lot. It'll come up in almost every homework. Okay, so part F is how does your model change if the population's decreasing instead? So, I don't know, people hate the town or everyone gets sick. So we've got, here's the original model right here. That was when the population was increasing by 3.2% every year. Oh, sorry, we got to do E also. Quick sketch of the graph. All right. Well, we know initially, when the year was 0, basically, we had 6,000 people. So I'm going to put a dot right there. And we know that 1 year later, I'm just going to put 1 right there. 1 year later, it was 6192, so it was just a little bit higher. Whoop, just a little bit higher. Well, it didn't double until you got 22 years later, so that's way down here somewhere. Let's say that's there. 22 years later, now we're at 12,000. And it turns out you can pick some other values in here, and if you plotted enough points, at 10 years, which is roughly here, we had 8,000 people, so it's kind of like this. So, and if you remember, things that have this form are going to be exponentially growing. Exponential growth. So that means that the population isn't going to grow in a line, like a straight line. It's going to grow like this, where it starts growing faster and faster and faster. And if you kind of think about, well, what would have happened beforehand? Well, it kept growing at 3.2%. So if you go backwards in time, the population should get lower and lower and lower. And it's never actually going to reach negative numbers because you can't have negative people. So it really, over on this side, it approaches y equals 0. Or I'll say p equals 0, because it's really population. And so the y-axis is really our p-axis. Okay. Over on this side, it shoots off to infinity, which isn't necessarily realistic, but for this model, for now, it is. Okay. How would the model change if it's been decreasing by 3.2%? So remember, here's our original model right there. Well, that's an increase of 3.2% every year. If it's decreasing, then I want to take my population, which started at 6,000, and instead of 100% plus 3.2%, I want 100% minus 3.2% because it's going down by 3.2%. That's going to be 96.8%. Well, in decimal form, that's 0.968. So instead of multiplying by 103.2%, I'm going to multiply by 96.8%, which is 0.968. And that's going to go to the t, depending on how many years that I'm looking at. And if we were to graph this thing, well, I'm multiplying 6,000 by something less than 1 over and over again. So then that's going to end up looking like I start at 6,000, and instead of going up exponentially, I'm going to go down exponentially like this. So that's going to be exponential decay. And you can kind of picture, well, if I keep decreasing by 3.2%, way in the future at some point, I'm eventually going to taper off and have nobody left. So it'll eventually approach 0 over here. So I'll write this asymptote is y equals 0. Or p equals 0, actually, let's say. That's the population. Okay, hope that helps a little bit.